So I have x plus 15 squared is equal to negative 5. So I just moved that over, right? Because it was plus 5 over here and I just moved it over. In order to get rid of that square, what do I do to both sides? Square root, right? What do I know about any number that's under the square root that's negative? What kind of number do you get?
I.
You get an I, you get an imaginary. Is that a real solution? Nope. And it's plus or minus the square root of I, right? So how many real solutions do you get?
0.
See how that's the answer? So whenever they give you a binomial square, just use the square root rule. Don't try to factor it. Oh, I guess I already did it. In the equation, k is a constant. For what value of k does the equation have exactly one real distinct solution? Okay, so when they're asking you that, they're asking you to complete the square. Because if it has one distinct real solution, that means that they want it to be a perfect square. So this is how you figure out what the perfect square is. You take, I might as well tape this too. Am I still taping? Yeah, I'm still taping. So let me write that down. So we have 2x squared plus 5x. And then I'm going to say this is equal to k. Okay. So now I'm going to complete the square. So I have to take this number and I need to divide it by 2. Because I have to factor the 2 out.
Okay.
So this is x squared plus 5 over 2x plus some number is equal to k. Now I'm going to take this number, I'm going to divide it by 2 again, and then I'm going to square the whole thing. That's actually how you complete the square, and then that number goes in there. Okay. So 5 over 4, and then you got to square it.
So 25 over 16.
So this is 25 over 16. Okay. Now that that's a perfect square, I can rewrite it like this. It's 2 times x, and then I just take the square root of that. What's the square root of that? Isn't it that number?
Mm-hmm.
So I'm going to put the same sign as the sign in the middle, and then that number there, the square root of it. So this is 5 over 4. And now let's look at my answer, because this is that thing squared. What did I miss? 2, 4. Does the equation have exactly one distinct solution? Did I do something mathematically wrong here? Two, 4. Oh, I know what I did wrong. When I complete the square, I actually have to take this and multiply it by 2 and put that number over here. So what's 25 over 6 times 2?
16 or 6?
16, sorry.
Times 2.
Mm-hmm. So 25 over 16 times 2. What happens to this 16 and that 2?
Oh, 8.
So if this is equal to 0, then what is k equal to?
Negative that.
Mm-hmm.
Uh,
That's how you get that. I know I did mine differently than the way they did theirs, because they used discriminant, and I just used the completeness square method. But whatever number you stick there, you have to also stick the same number over there. So that's the thing I forgot. All right.